All right. So today, this video is all about my favorite type of number in the whole wide world, prime numbers. And the goal of this video is to help you to be able to identify what numbers are prime and what numbers are not prime. And then my goal is for you to memorize the first 6 prime numbers. So let's remind ourselves what a prime number is. Prime number is a number that has exactly 2 factors, 1 and itself. Okay. Now, if a number is not a prime number, then we call it a composite number. A composite number would be a number that has more than 2 factors. So prime number has exactly 2. A composite number has more than 2. And obviously, you need to know what a factor is. This is where I guess I have to say goodbye to my face here so you can see. Factors are numbers that multiply, factors are numbers that multiply together to make another number. And so we're going to be looking at numbers to decide if they're prime, exactly 2 factors, or composite, have more than 2 factors. And we're going to use the letter F to help us to figure that out. F stands for factors. If you say it's a composite number, that means you have to prove it's composite by giving the other factors besides the 2, but what I call bookends, or the 1 and itself. So we're going to go ahead and find the first 6 prime numbers and memorize them. So the first number that we're going to focus on is the number 2. And I'm going to go here and I'm going to go ahead and draw my F. And we're going to decide if 2 is a prime number or not. So the first 2 factors of any number are 1 and itself, in this case 2. And if a number has only these 2 factors, and I call those factors bookends, they're on the ends, and all the other factors would be in between. Because a bookend, if these are books that I don't want to fall down, they invented these cool things called bookends, and they go one on each side, and it keeps the books from falling down. Those are bookends, and the books go right in between them. So what we're looking for is, are there any other factors? Well, since there's no other numbers between 1 and 2, this is indeed a prime number. And so I'm going to go back here, and we know that 2 is indeed a prime number. It has only 2 factors, 1 and itself. So now let's go ahead and take a look at the number 3. So if I look at the number 3, I know the number 3 has 2 factors, at least 1 and itself. Those are my bookends. If that's it, then it's prime. If there's any other numbers that fit inside 1 and 3 that multiply together to make 3, it would be composite. Well, the only other number that I would test would be 2. And I would ask myself, is 2 times anything 3? And the answer is no, which makes 3 a beautiful prime number. So if we go back here, we know that 3 is our second prime number. The next number we're going to try is 4. So let's go ahead and draw my F for factors. And we're going to go ahead and test the number 4. Well, the first 2 factors of 4 are 1 and 4. Those are my bookend factors. All other factors, if there are any, would fit in between there. The next factor that I would try would be the 2. So my question to myself is 2 times anything equal to 4? Well, I know that 2 times 2 is 4. So I'm going to use that little upside down horseshoe there to kind of show that 2 times 2 is 4. And that is the proof that I need to say that 4 is nothing more than a lame old composite number. And my proof, because you always need to provide proof, is that 2 times 2 is 4. We have more than just those 2 bookend factors. So when I go back to my list here, I can see 4 is not a prime number because I'm going to get rid of this thing here. I wonder if I can hide that. There we go. 4 is, I don't think I can. 4 is not a prime number, and so we crossed it out. Let's try 5 next here. So I'm going to go ahead and draw my F and 5. I know 1 times 5 is 5. Those are my bookend factors. The next number I'm going to try is 2. And there's nothing times 2 that is 5. So we're not going to put 2 down. How about 3? Nope. 3 times 2 is 6. I skipped right over that. How about 4? Nope. There's nothing times 4 that is 5. And then I already have 5 there, which means 5 is a beautiful prime number. And so far, we know that 2, 3, and 5 are prime numbers. Let's go ahead and test 6. And you can be thinking, is 6 a prime number? Well, we've got 1 and 6. Those are my bookend factors. And if any other factor pairs fit inside, we know it's a lame old composite number. Well, I look at the number 6, and I know 6 is an even number. And all even numbers have 2 as a factor. So I know for sure 2 times something is 6, and I know 2 times 3 is 6. The next number that I would try is 3, but since it's already there, I'm good to go. 6 is just a lame old composite number, and my proof is that 2 times 3 is 6. And so if we go back here, 6 is not prime because 2 times 3 is 6. Let's go ahead and look at 7 and 8 at the same time. So I'll do an F for 7 and an F for 8 just to save me going back and forth here. All right. 7, I know my bookends are 1 and 7. There's nothing times 2, nothing times 3, 4, 5, 6. Nope. 7 is a beautiful prime number. Let's go ahead and look at 8. We have 1 and 8 are my bookends. I'm going to see if any of the other numbers fit inside. And I know right away when I think about testing 2, I know that 8 is an even number. So I know 2 times something is going to be 8. And I know that 2 times 4 is 8. The only other factor I'd have to test in the middle is 3. And there's nothing times 3 that's 8. So I know that this is a composite number. And my proof is it has more than just 2 factors, 1 in itself. It also has 2 times 4, which is 8. So if I go back here, I know 7 was prime because we only had our bookend factors 1 and 7, but 8 was not prime. It had 2 times 4. Let's go ahead and test 9 and 10 next. We'll do this F for 9 and this F for 10. Now, we know that even numbers are going to be composite, except for the number 2. We'll talk about that in a second. But the question is, are all odd numbers prime? Well, let's test this one out. 1 times 9 is 9. I know that. If that's where we leave off, then we know it's prime. I know 2 is not going to work because 9 is an odd number, so 2 won't work. But I do know that 3 times 3 is also 9. So even though 9 is an odd number, it is composite. And my proof is that 3 times 3 is 9. If we look at the number 10, right away I know it's going to be composite, and here's why. I know 1 times 10 is 10, and because 10 is an even number, I know 2 times something is going to be 10, and in this case it's 5. And there are no other factors. 3 doesn't work, 4 doesn't work, and there's 5 there. So this is another composite number, and the proof is that 2 times 5 is 10. So if you look up here, we knew 9 was not prime, 3 times 3, and 10 was not prime, 2 times 5. If you take a look, the only even prime number we get to have is 2, because 1 in itself, that is the 1 and the 2. Let's go ahead and test our final 3, 11, 12, and 13. We'll do these all together. 11, 12, and 13. That 11, that was a terrible 11. Let's do it that way. 11, 12, and 13. All right, for 11, we've got 1 and 11, and I'm going to test my other ones. 11's odd, so 2 doesn't work. There's nothing times 3 that works. Nothing times 4, 5, 6, 7, 8, 9, or 10. There are no other factors that fit between my bookends. That makes 11 a beautiful prime number. But let's check out 12. I'm going to use red here. We know 1 times 12 is 12. I know 12 is an even number. So I know 2 times something is going to be 12, and that something is 6. Right off the bat, I've already said it's definitely not prime, but we can also figure that 3 times 4 is also 12. So 12 is definitely composite, and we have different amounts of proof here. We know 2 times 6, or we know 3 times 4 are both our proof that it is not prime. It's a lame old composite number. And when it comes to 13, you should already know 13 is a prime number. It's my favorite prime number of all. There are no other factors. 2, 3, 4, 5, 6, 7, 8, 9, 10. There's no other factors in between 1 and 13. And so 13 is a beautiful prime number. So if I go back here, 11 we said was prime, 12 was composite. And we don't just have one piece of proof, 2 times 6. We have a second piece of proof, 3 times 4. And then 13 we said was prime. So if we look at just our prime numbers, I really want you to memorize them. And there's a really cheesy song. It goes like this: 2, 3, 5, 7, 11, 13, 13, because 13 is the best. We say it twice. So go ahead and sing it with me. 2, 3, 5, 7, 11, 13, 13. Memorizing the first 6 prime numbers is extremely helpful because we're going to be using these prime numbers in a couple days to do something really, really fun with them. I just want to spend a second and talk about why I left the number 1 off. I didn't even include it in my list. And that's because 1 is neither prime nor composite. If I say 1 and itself, well, 1 times 1 is 1, which means the only factors of 1 is 1. 1 times 1, which means 1 only has one factor. But if we go back to the definition of prime and composite, a prime number is a number with exactly 2 factors, 1 in itself. Composites have more than 2 factors. Well, 1 doesn't fit either of those definitions. And so 1 is neither. Our first 6 prime numbers, 2, 3, 5, 7, 11, 13, 13. What you're going to do next is I'm going to give you some numbers. You are going to draw your F on some scrap paper, and you are going to decide if the numbers are prime or composite. And I will provide the answer key to kind of show you what you should have done so that if you are confused, you can look at it. So you will be doing the next activity, which is called prime or composite. Figure it out.